Good afternoon. This is the lesson 11.4, three-dimensional figures. Now, this lesson is not complicated. It's just a little bit hard to see visually sometimes. It all depends on what kind of learner you are. Now, this lesson has to do with polyhedrons. Now, what is a polyhedron? A polyhedron is a solid that is bounded by polygons called faces. Each vertex is a point, so all of these are considered to be vertices. Each edge is a segment of a line that joins two vertices. An edge, edge, edge. Pretty much it's all the lengths pretty much here. Now each face is a portion of a plane. So anytime you have a flat surface, that is considered a plane. Now here are 5 examples of polyhedrons. I'm going to zoom into them so you can see what they are. I'm not going to really worry about the table right below it. Okay, this is a tetrahedron. This is a cube, which we're very familiar with. This is an octahedron. This is bounded by, I believe, 8 equilateral triangles. This one's bounded by 3 equilateral triangles. This one's bounded by 6 squares. This is a dodecahedron made up of pentagons. And this is, see if I can say it, an icosahedron, which is made up of nothing but equilateral triangles. I can't really tell how many that they are. Now, like we said, this is again a polyhedron. Now, I want us to jump to page 332. Now, 332 in your journal, here are some examples of polyhedrons and non-polyhedrons. Here, this is an example of a polyhedron. This is an example of a polyhedron as well. These are not examples of polyhedrons. So what's the difference between a polyhedron and something that is not? Well, it all has to do with the faces of the polyhedron. If the polyhedron's faces do not bend, then it's a polyhedron. If they have any type of curvature, like this cylinder, then it's not a polyhedron. This right here, this is a cone. Even though its base is a flat surface, everything else, it's not. It's curved pretty much. And in a sphere, everything here is curved. The second concept that we needed to know, excuse me, it's what happens when you have a two-dimensional figure. Let me zoom out, kind of like this one. This is a right triangle. And what happens if you were to rotate this around an axis? So what I have here is a right triangle, and I have something that is going to rotate it. Now, if I do it slow, it's really not going to help. But if I do this really, really quickly, and if I kind of tilt it on the side, let me try to get a good angle. Now, what kind of shape is this going to create? Now, if you were to look at it from a top point of view, oh, a little big, hold on. Okay, from a top point of view, and you were to rotate it multiple times, then you would be creating what kind of figure? And in this case, it would be a cone. Now here you have a rectangle. If you grab this rectangle and you rotate it several different times, you do it really, really fast, what kind of three-dimensional solid are you going to get? You're going to get a cylinder. If you grab this right here and you rotate it multiple times all the way around, it's going to create only part of a cone. We call it like a truncated cone. The next concept I want to talk to you guys about is what happens when you have a solid and you cut it. So this is super high tech, guys. I'm using a toilet paper roller. So in this toilet paper roller, assume that the little white piece is not there. This is part of a toilet paper roll. If I were to slice this toilet paper exactly parallel to its base, you're going to see that you're going to have a round surface. Okay, so once again, if I were to slice this, you would get a round surface. That's called a cross area. Now here I have the same thing. Okay, here would be my toilet paper roll. It's in the shape of a cylinder. I know it's kind of dark. But if I were to slice it instead of around, I were to slice it vertically, you would get an actual rectangle. Okay. So part of what we're going to do is we're going to describe what shape is formed by the intersection of a plane and the solid. Please turn your journals to page 331. On page 331, this is where your examples are going to go. It's a very short lesson. Example 1, 2, and 3. So let's go ahead and start with example number 1. It says, tell whether each solid is a polyhedron. If it is, name the polyhedron. Now, in the first one, you can see that none of the sides here are curved, and all of these sides are bounded, are pretty much polygons. So is this a polyhedron? Yes, this is a polyhedron, and this is a rectangular prism, or a box, pretty much. Now, this one, all of the sides around here are actually two-dimensional figures, and there is no curvature. So yes, this is a polyhedra. Now, what will be the name of this? Well, this has 6 sides in the base, and they all meet at one point at the top. So we call this a hexagonal, because it has 6 sides, hexagonal pyramid. And on the last one, you can see that there is curvature to the supposed faces of this figure. So is this a polyhedra? No. What will be the name of it? Well, we know it's a cone, even though it's not a polyhedra. So this was example number 1. Example number 2, it says, describe the shape formed by the intersection of the plane and the solid. So for A, you can see that this plane is cutting this hexagonal, I forgot, I guess it's hexagonal prism. And the shape that it's creating, let me use a little highlighter so you can see what's going on here, happens to be a hexagon. Okay, so the shape is a hexagon. Here, you have another prism, or you have another polyhedra, and the plane intersecting here, creating a triangle. Now, why is that color? Not sure. Now, on the next one, probably can't see it very well, but the shape that it's creating here happens to be a rectangle. Here, even though it looks ovalish, but it's actually a circle. Here, this plane cutting this sphere is also creating a circle. Now, very interestingly, on this one, you have a cube and the plane is going at an angle. So it's actually creating a trapezoid. So what do you have to do? You have to write down pretty much what every one of these is going to be. This one, it's a hexagon. B, It's a triangle. That's a two-dimensional figure created by the intersection of the plane and the shape of, and the solid. For C, it's creating a rectangle. For D, is creating a circle. And also for E. And for F, it's creating a trapezoid. That is an ugly looking R. Trapezoid. So that's example number 2. Example number 3, a very important concept in calculus when you guys are going to be actually rotating graphs around an axis of rotation, creating three-dimensional figures, and actually finding out their corresponding volumes. Now here, if you were to grab this rectangle and rotate it around this line right here, like actually rotating it, you're actually going to create a cylinder. I think that's how you spell cylinder. Remember, I teach math, not English. Okay, so you're going to create a cylinder and says identify and describe the cylinder. So it's going to be a cylinder of radius 4 and height of 9. If I wanted to draw this, I guess I could. It's going to look something like this. Where this right here is the two-dimensional figure that you have above, where this is 4 and this is 9. If you rotate this polygon right here, the one that's being shaded all the way around, it's going to create a three-dimensional solid, which is the cylinder. Here, if you rotate this right triangle, it's going to create a cube. Now, if I were to draw the cube in three-dimensional form, it's going to look something like this. It's going to have a radius of 2. Whoops. A radius of 2 and a height of 5. So this right here is going to be 5. So 2 and 5. So this two-dimensional solid rotated about this line right there will create a three-dimensional solid. Very important concept for calculus. Now, this is pretty much the lesson. So make sure that you guys are doing your journal. Make sure that you guys are doing your extra practices on the online homework as well. See you guys later.